Hello everyone, I'm Xiaogang. In this lesson, we will cover the basics of multithreading. But there is a point I need to draw your attention to, which is to emphasize. Before we officially begin, there is something I need to emphasize to you. You must not come in with an arrogant attitude, thinking you already know all this. Just watch how I write the code, then write the code process yourself, and then add your own ideas into it. Then your multithreading will basically be good enough, because this knowledge area is difficult, very in-depth, and it is not something for a beginner. No, it's beginner level content. But in order to help you quickly expand your skills, just jump straight into practice. Because we first look for a job. You must be an ultimate excellent engineer to be able to find a job. So excellent, the ultimate part, multithreading, is a hurdle you cannot bypass. But first of all, the content of this lesson is to first supplement some basic concepts for you. Then tell you to what extent you need to master and what extended knowledge there is that you can further learn. Okay, let me first explain. That is to what extent you need to master. That is, you need to know now. The Unreal Engine has many threads. Then there is a thread, which is its game main thread. That is, most of our operations are all on the game main thread, including code like ours, or operations executed on Blueprint. Unless we are all doing it on the game main thread. So this game main executes frame by frame. That all other threads will cooperate with the game main thread to advance this process frame by frame. For example, the rendering thread will assist the game engine in rendering work, and the rendering thread lags behind the game main thread by a possibility of 1 to 2 frames. Then the audio thread helps the game engine process audio. This thread, along with various other threads, each takes on corresponding role. Okay, you just need to understand this much. As for the remaining content, you can completely skip it. That's perfectly fine. For the rest of what I'm about to say, just absorb as much as you can. There are game threads, audio threads, render threads, and some background threads, as well as some task threads. There might also be some HTTP communication threads. There might also be some IO threads. Just know this. That's enough. Let's continue. So first, let's look at the document. I'll only pick a few sections from this document to explain, because all of this is advanced knowledge. Before you reach 20K, don't look at the stuff. You won't understand it, and you won't be able to learn it either. Okay, so first of all, we need to look at this. Look at this. Let me take a look. Which one should we start with? Let's start with this one. Note that it's this article. Render thread will only look at 1 or 2 paragraphs. Then in Unreal Engine, the render's rendering pipeline is all done on its own render thread. This thread is called the render thread. It lags behind the game thread by 1 to 2 frames. That's how it is. That is, you modify the position in this frame, but actually on your screen, you will see this actor. Its position is transformed. Then the things in the scene become corrupted. You have to wait until the next frame to see such a result. Then, because it involves multi-threaded interaction, we must consider the safety of memory, read and write threads. However, these threads run at different speeds, which will cause contention. If contention occurs, it is very likely that on this computer, it will never fail. This is because one core on this computer might be stronger and another core might be weaker. And if it happens that the stronger core is running the game's main thread and the weaker core is running the game's rendering thread, then the game's rendering thread will never catch up with the main thread. Then nothing will happen. So switch to another computer. It tells the game main thread to be slower. The render thread needs to be faster. They ended up competing with each other today. It's possible that the render thread has to wait for the game main thread, but usually that doesn't happen. Usually it's the game thread that waits for the render thread. This kind of problem is very hard to debug, and this kind of bug is also very hard to fix. You can see that on this side it says the time difference is about 10 times. In fact, most people can't find this bug and can't fix it either. So these methods give a simple example. This example is about when the main component is registered to the scene. Then the game thread will call this method to perform a relevance registration. It will cache its own actor pointer. Then, when the renderer is rendering in a single rendering process, the rendering thread needs to call this dynamic element, the element used for drawing. that it may need to read the actor's properties, right? Once it reads the actor's properties, but this actor is not managed by the rendering thread. This actor may have been destroyed. It may have changed. Then if this actor or this object has already been recycled when you read it, then congratulations, your rendering thread has crashed. So what should you do in this case? Very simple. Just take the property you want to read and make a mirrored copy of it. Then there will be no problem, because after you copy it, it becomes a value. You die. This is a group value of yours. The game thread truly controls where this value resides. You can change it freely, and I will periodically update my copied mirrored value. Okay, so how do we avoid such problems? You cannot find a completely tested solution. In other words, this kind of testing, you cannot achieve 100% testing. You can only guarantee about a 95% assurance rate. So the best approach is, when we write code, you must thoroughly understand the game thread and the render thread, the interaction between them. You know which one appears first and which one follows behind. How they use decisive conditions to determine that no competition occurs. So this is our development approach. So how do we do it? Then it's very simple. We take the data that someone needs to use. We separate it. That is, the game thread, you use your own data, and the render thread, you use the render thread's data. Neither of you should affect the other, right? So how do we do it? It is to completely separate this thing. After separating it, it's equivalent to saying, then we regularly update our mirrored resource. So actually, look here, just look at this. Next, look at this position. Look, there's a stat unit here. We often use this command, right? This command helps us read the bottleneck. Jump to this place like this. This command, then you can see this command on the right side. You will see our CPU thread and our GPU. Which one is slower? And then it's at this bottleneck, but my scene is empty. So you can see there's no problem. Okay. So we mainly need to look at this. Look at this. You can see your world, your level, your sync component, your primary component, your light component. Does this look familiar? Does it look familiar? So this your pretty component, it is the parent class for rendering. What is it? It is a scale match. Scale match and such. They are essentially these subclasses of your parent, right? And these are the ones we often use. So how do we copy the resources to the rendering thread? Then we define these classes. Starting with F, you can see this F-sync if you have done editor development work and you want to render such a viewport. For example, we have such a viewport here. We create a new material here. Sometimes to make such a viewport, this is another world. This is a U world. So how do you make it? Render. You need to render it as an F scene. That's it. The game thread will not be able to modify itself. That's what it means. Then the corresponding components also have a renderer version. They will then record this rendering information. And this FC value is very critical. In our viewport, it corresponds to this thing. So these classes, starting with F, correspond to these classes, starting with U. They have a simple correspondence based on this relationship. After this correspondence is established, you can operate it very safely in the renderer. Then you don't need to look at this information at all. I don't want to look at this at all right now. Then let's continue back to below this article. Okay, so here I've explained to you this thread-specific data structure. You just need to know that such a specific data structure exists. That's fine. And note that this sentence is very important. The game thread will block at the end of each T world until the render thread catches up by 1 to 2 frames. When the render thread is very far behind, the game thread will block. Then waiting for the render thread to fully catch up is not advisable. In fact, sometimes it supports an asynchronous streaming, mainly some asynchronous mechanisms to prevent blocking. So how do they communicate with each other? The communication method is mainly through this macro, enqueue, arcade, Unicode render command, which is carried out. This way, you write the code you want to execute on the render thread into this macro, and that's it. Then these are some specific, these threads, methods for continuing to track the progress of the render thread. And this command is used to make the game thread wait specifically. Then we can paste this macro for everyone to see. Take a look. Maybe I'll look for it for everyone later. His name might have changed. How? Take a look at this one. because if you read the book, because sometimes you find that there are some changes. Let's ignore this part. And this name is for the main shot here. This place, it has a boolean. It's fine. We'll use this later too. It is a method, also called this. This is called the flash. It should be. This is waiting for the render thread to complete all the cached render commands. This can only be used in the game thread. Look at this place. This is the work it needs to do. This is the rounder. And you round the command. This pushes the lambda here to the render thread for it to execute. Okay. Now that we have the concepts of the game thread and the render thread, let's move on to the next part. You can completely ignore these things. No need to look at them at all. Don't worry about what they say at all. Let's just erase this. And then, this part is about specific rendering details. We don't need to look at this either. Then, let me check. And here, it introduces parallel rendering. And this part introduces, that is to say, U is actually a kind of this. Such a consequence. Just these words. These words need to be looked at. The game thread was discussed. The render thread was discussed. So actually between the RHI thread and the GPU, here it comes again. Actually, all of these are threads. They haven't reached the GPU yet, although it is called the render thread. It is still essentially running on the CPU, because the real interaction with the GPU is that it needs to push commands to the GPU. The GPU executes things internally. So Unreal Engine, it is configured as a renderer for the last frame. That is to say, when our render thread processes frame n, the game thread is actually processing frame n plus 1. Unless the render thread is faster, usually it is not faster than it. Generally, it is 1 frame slower. Sometimes, for optimization purposes, to increase rendering parallelism and effects, we add an RHI thread. This makes the situation more complex. That is, when the RHI processes frame n, the render thread can prepare some content in advance. It can complete the visibility calculation for frame n plus 1 and move ahead of the RHI thread. So, in fact, when the game thread processes frame n plus 1, the render thread can process commands for frame n or frame n plus 1. So, the RH2 thread can also translate to the command for frame n or frame n or frame n plus 1. So it depends on these execution times. So how to do it? They use some functions and commands of these structures, allowing arbitration. In general, the order of submission is the same as the submission order in our single thread training. This ensures consistency. Okay, so this is the process of submitting commands. Good. Let's stop here. Basically, we just need to know these things. And then you don't need to. Then let's go back to our original concept. Knowing that there is a game thread. Know that there are ready-made rendering solutions. Know that there are ready-made audio solutions. Know that they communicate with each other. And there may be competition. That's enough. I'm really afraid of giving everyone a long-winded explanation and then overwhelming everyone with information. Okay, so we'll erase these. We'll ignore them. Then let's talk about how to expand learning. First of all, you need to watch this video. It helps to understand Unreal Engine's real-time rendering. That's it. You must watch this video. This video, although the label is not, it's this one. Although its label level is not high. But this video is very good. Very good. You can watch it several times. If you don't have time, you can look at this diagram here. Just take a look. Do you know, from a CPU to this GPU, it goes through some processes, what each process does, right? Then, once you can understand this, you'll basically have some knowledge. We can continue learning further. Now, the most important thing is, you can look at this rounder section. There is a complete analysis of the Unreal Engine, available right out of the box. This thing is extremely powerful. It explains everything to you completely, but don't try to learn it right now. This part is all advanced knowledge. It's all advanced to expert level knowledge. Unless you have at least 3 years of experience looking at this stuff, will just confuse you. So don't look at it. Okay, so this is our resource. That is actually this resource. This Excel has been released for a long time. Everyone should have a copy. This is okay. This one is broken. And then there is this one. This test graph. It is here. Find this. So it's him. So it's here. Okay. This is it. This one is also very powerful. We won't give it. This tells you how to use these threads in UE5. How? Don't write your own thread history. There's absolutely no need for that. You just use your own method, combined with Unreal's mechanism to fully implement it. This is you. We need to thoroughly master this content. I won't expand on it here, because these are all articles by experts. I don't need to follow the usual routine, because you don't need to worry about the content that follows. There will be at least 3 chapters of hands-on practice, all based on my personal experience, which you probably won't find online. And this hands-on practice is very good. It has already been verified by myself, and it's especially convenient for getting started, especially for learning. That's why it's placed here. Okay, so for this lesson, it should take about 15 minutes. Then we'll go over a bit more support for you. Okay, then let's set a breakpoint here. Still a thread. Then we go into the game thread. I'll delete this. This is useless. Leave it here as a placeholder. Create a level yourself. After creating a level, you can set a breakpoint and follow along with me. Okay, then we can see here, right here, let's also specify this map. This knowledge, it's not knowledge for beginners, but you can learn about it. If you don't understand clearly, you can skip. You can jump directly to the later part. Our online game development. There's nothing much here. Actually, there is no multi-threading in online game development. You know, because multi-threading is something that only we programmers see judges in the news. When we need to do a lot of things, only then do we do it. Then we drop an actor into it. Then we set a breakpoint in the tick here. We mainly come to our battle. Then we directly go to the very top here. Okay, you can see there is a windmill here. After windmill arrives, it will launch Windows Startup. Then you don't need to worry about this. And this is too close. So when you execute to this point, the engine has actually already exited. We can set a break like this. Now everything is during the engine execution process. Then after this startup comes in, there is this gradient. Actually, it is our main function. You can see there is a tension here. You can press this to take a look. We are just going through it for everyone. We won't go into detail on this. This is a thorough analysis of the engine, right? Then this gradient, you can move it over. Merely look at this engine tick. You can see here the main thread. We mainly look at this engine tick. At the engine part, there is engine serialization, editor serialization, right? Then a pre-compilation of this engine. Then this place. This way of writing here is this struct. When it hooks, it will execute this engine. This exit. Doesn't this way of writing look a lot like our smart pointer? Custom deleter. Then there are some delegates here. This delegate is very important. That is to say, it has some stages. You can see, this means it is divided into different stages. It will execute this delegate. If you want to have the engine at this point, that is to say, you want to embed your code here. Okay, just bind this delegate and you're done. Good. We ignore these for now. For these, we mainly look at this. This initialization is complete, and for this part, we mainly look at NGT. You can see that inside NGT, there is a loop, tight loop, then end loop, then inside the next loop. We continue going down. Loop, that's it. Then there's a GNGT here. GNTick is fine. We continue going down. This place is a bit hard to find. And then take Unreal Add Engine. Then here, Unreal Add Engine enters here again. Then to editor engine, you can see it's one T nested inside another T. Because this GNG is the engine framework, he is no longer a game framework. He is an engine framework. You see this editor engine, because you know our editor's PR. Emode is actually an editor engine. Then it wraps a game scene. And then finally going down, it goes to world tick. You can see this is where we start ticking our world tip. Then it all actors, they will all start their tick. Then start ticking. Then this place ticks. Then we just kept walking. Walked to test graph. This street. He goes to handle some ready-made tasks. Saw us walking. Then arrived at this place. You can see this place came from walking here. Okay, actually we have already explained this part here. Roughly went through it. That is, it has an engine. It has a main tick. Inside the main tick is essentially our get rate. It keeps ticking. When you trigger the corresponding process, It will use these graphs, take actor to execute the work inside. Its outer layer is actually done through this kind of GN scene editor, and scene ticks down layer by layer. This is the world. There are many actors in the world. Then they are divided into many tick groups, still ticking here. Then some components are ticking. Then we manually look here. You can see we go to the very top, our games ray. Actually, it wasn't called games ray at the beginning. It only later changed its name to games ray. Then we found a county town. And the county town specializes in doing the most core work within the game. So we call it games ray, and some of these are backend related, so we don't worry about them. And these, yeah, we can see some IO related, right, some things from the ready-made terms, and these third, and also DDC. Then we mainly look at HTTP. Looks familiar, doesn't it? AR high rounder 3 looks familiar, doesn't it? ATCP, UDP, and then this A2 related to a 2, then related to a 2, and then roughly you just type roughly, you'll know. That's enough. Okay, then we'll stop here for this lesson. And finally, everyone must clear their minds and refresh their thinking. Do not get confused by those things. Those things are advanced knowledge. For now, we only need to master the intermediate level. We will create our own threads and interact with the game thread, the audio thread, and the rendering thread, and avoid creating race conditions that lead to problems that are simply impossible to trace or cause issues that can never be found. That will be enough. Okay, and thank you everyone.